Hello again, my fellow pilots and aircraft maintenance personnel. Your host is Haytham Aly, and I'm an aviation technical instructor. Today, I will speak about the outflow valve or discharge valve. It is a vital component in the aircraft pressurization system. So, before talking about the outflow valve, I need to tell my fellow pilots and aircraft maintenance personnel, this is only a performance support tools. It is not a formal training. So always use your formal manual before aircraft maintenance and operational activities. So let's go. As I promised, I will speak about the discharge valve or outflow valve. It is for the pressurization system, cabin pressurization system. Okay, today we will speak about the component on the outflow valve, how it is constructed and how it is powered. As you can see here, this outflow valve is electrically powered by an actuator using three motors. So regarding construction, the outflow valve is constructed from two doors, an aft door and a forward door. Two doors are operated using any motor from the three motors to operate the doors of the outflow valve. So as you can see, the discharge valve consists of two electrically operated doors or panels. This is regarding construction. Okay, so regarding the power, on the outflow valve doors, we have a mechanical linkage. This mechanical linkage operated by an actuator, and this actuator may be powered by three motors. We have three electric motors to operate the outflow valve. As you can see here, two AC motors and one DC motor power the valve. So why we have AC and DC? We need different aircraft electrical power, and also regarding the speed. If we need to operate the outflow valve in a fast speed or a slow speed, so that we may have AC motor and DC motor. So as a total, we do have at least three motors power the outflow valve. This is for redundancy. And probably on most aircraft, two motors will be operated automatically from the cabin pressure controller, and the pilot will not control the opening and closing of the outflow valve. And a third motor may be controlled manually from the cabin pressurization panel, just in case the two automatic motors fail. Okay, everybody. So what else on the outflow valve? We may have a potentiometer which feed signals to the valve indicator on the pressure control panel, or in the modern sophisticated aircraft on the ECAM display or ICAS display. The pilot need to know about the status of the outflow valve. It is open or closed. So we do have a potentiometer which feed signals to the valve indicator on the pressure control panel to allow the pilot to know the status of the outflow valve. As you can see here, we have a cabin pressure control panel, and on the panel we do have the status of the outflow valve. It is open or closed. Fully open or fully closed, whatever. Okay, whatever the position of the valve. So this is regarding indication. Okay. So also on the outflow valve, we may have a tachometer to feed back the valve operating speed or valve rotating speed to the controller. As you can see, the tachometer, this provides a feedback signal from the discharge valve motor to the controller to improve the motor's response. Because in some situations during flight, we need the outflow valve to close or open in a very fast pace or in a lower pace. For example, if the automatic control is operating the outflow valve it will operate in a less speed. But if the manual control going to the pilot need to close or open the outflow valve in a much higher speed. So the outflow valve may have a tachometer to give a feedback signal regarding the discharge valve motor operation to the controller. This is why to improve the motor's response. Okay, everybody. From the actuator to the doors of the outflow valve, and as I told you, we do have two doors, a forward door and aft door. From the actuator, we have an operating linkages, which transform the electrical power into mechanical power to operate the two doors of the outflow valve. These operating linkages are arranged in such a way as to open the forward door downward while simultaneously opening the rear door upward, so that the operation and the opening of the outflow valve will result in what it called a venturi effect. Because why we need, from the mechanical construction of the outflow valve, a venturi effect when it is open? This is to provide additional thrust during flight. When the outflow valve is operating during flight, yes, on the ground it is fully open, and during takeoff and cruise it is closed, but it is not fully closed. It do have what it called a cruise limit. It is not fully closed, but it will be a little bit open to ventilate the air from the cabin to the outside of the aircraft. And as I told you, or as you know, we do have a high pressure, very high pressure inside the aircraft and very low pressure outside the aircraft. For example, in the Airbus A320, we have the cabin at 8,000 feet, and the aircraft may be flying at 35,000 feet. So the air will go in a very high rate or very high velocity from inside the fuselage to the outside. So we need the outflow valve in the cruise detent to have a venturi effect to be like an advantage in the thrust. We don't need the outflow valve to do a drag on the aircraft during flight, but we need the outflow valve to do to add value to the thrust to the aircraft during flight. So when the outflow valve is open in the cruise detent, we need like a venturi effect to provide additional thrust during flight, and the outflow valve don't make a drag on the aircraft during cruise phase. Okay, everybody. So the purpose of the thrust nozzle of the discharge valve is to create a venturi effect on the discharging air. This results in additional thrust being produced, which in the cruise position can amount to some 60 pounds. 60 pounds of thrust. Okay, everybody. So, as you can see on the actuator, we do have three motors. Motor 1, motor 2, and third motor. This is why, because the outflow valve mainly controlled automatically from the cabin pressure controller. And in the aircraft, we do have at least two cabin pressure controllers. So for redundancy, we have CBC1 will feed motor 1, and CBC2 will feed motor 2, and a third motor which will be controlled from the cabin pressure control panel, and the third motor which will be controlled from the cabin pressure control panel. So again, the discharge valve motors receive their electrical signal from the pressure controllers. This is for automatic control in the following pattern. Number 1 controller, or CBC1, will feed or control motor 1. And number 2 controller will feed motor 2, and a manual control input feeds the DC motor from the cabin pressure control panel, just in case the two automatic controller fail. So the pilot will have a privilege of manually control the outflow valve. Thank you for your good listening, and always stay tuned for my aviation nuggets. In the next series of this nuggets, I will speak about the cabin pressure controller, CPC, cabin pressure controller. Thank you for your good listening, and always fly safely and maintain your aircraft very safely, and stay tuned for my next nuggets. Bye-bye.